Hi, and welcome to the Supply Chain Lab, where we talk about supply chain analytics and how you can use those analytics to have some really good results in your supply chain. Today, we're going to talk about using averages, and we're going to use a procurement example to demonstrate what we're talking about. So why don't we jump right in here to this example? And the problem statement is as such. It says, I have a product that my company manufactures. It requires 10 individual components that need to be purchased individually, and all those are then assembled into the finished good, which is the sellable unit. Each of the components has a mean purchasing lead time of 10 weeks. That means from the time that I place the purchase order to the time that I receive the product on my dock door, as on average, 10 weeks. Final assembly is going to take 1 week. So in total, this is an 11-week process. It takes me 10 weeks to get the product in-house, another 1 week to get it produced into a finished good. So from the time I place the purchase order to the time I'm ready to sell a product is 11 weeks. So during my executive meeting this morning, the sales team shared their plan of a promotion that they want to have in 11 weeks, and they expect that that's going to increase demand by 50%. And the question is, can we, in supply chain, can we support this increased demand? So how do we take a look at this? Here's what we're going to do. So just as a pure graphic look at this, here's 10 different components. They all have a mean lead time of 10 weeks. And so as we mentioned, the question is, what do we tell them? Will we be able to support this promotion with enough inventory? So at first glance, if you think about this, you're like, okay, this should be 100% no problem, right? I've got a 10-week lead time to get the product. I need 1 week to pull it together. That's 11 weeks. They want to do this in 11 weeks. What's the problem? 100% no problem. We're good to go. I give them the thumbs up. Go ahead and run the promotion. Well, let's think about it for just a minute. Really, what we're saying is the mean lead time is 10 weeks. So on average, this is going to be 10 weeks, which means that half the time I'm going to get the product in less than 10 weeks. Half the time it's going to be more than 10 weeks. So really I've got a 50-50 shot at this at best, right? So half the time, 50%, meaning I'm going to get it on time. Half the time I won't. So maybe I tell them, hey, this is about a 50-50 shot that we're going to actually make this. Let's think about it a little further. What if it's only 10%? I mean, basically, I've got 10 products here. Any one of these could come in over 10 weeks. I may only have a 10% shot at getting this to work. Or let's think about it even a little further. What if it's 1 in 1,000? What if this has such a low probability that I don't even want to be able to tell them yes about this at all? How can we think through this of what this is really going to be? Well, let's use some analytics. First, let's take a look at the lead time and let's make an assumption that it's a normal distribution. I happen to know from the data, and we'll go through this in the second. This is actually a 2-part video. In part 2 of this, I'm going to go through and show you how we calculated what the actual distribution is. But I happen to know right now that it is a normal distribution. And by the way, if you've got plenty of data, years worth of data, most of the time, if you've got enough data, you can show yourself that it's going to be a normal distribution, so you're pretty safe in making that assumption, though not always. So you got to be a little bit careful, and we'll talk about that in the second half of this as well. So what does a 50% probability mean? Well, that means it's a coin toss, right? It means heads. I've got to get heads. It's a 50-50 shot. But not only does it mean that I've got to get heads, it means that I've got to get heads 10 times in a row, right? I've got 10 different components. Each one of these components all has a 50% probability of getting here in less than 10%. So what does that mean? To get 10 heads in a row, the probability of that is 0.5, which is the 50%, raised to the 10th power, right? This is what it would take if you ask me right now, what are the odds of flipping 10 heads in a row? It's 0.5 to the 10th power. It's 1 in 1,024. That's what 0.5 to the 10th power is. So basically, I've got less than 1 in 1,000 chance that I'm going to be able to support this. So the good news is I can tell them, no, we can't do this, but I'm not going to be long for this job if I just say no and don't have a corollary to that answer that says, no but, right? So what I'd like to be able to do is tell them, hey, this isn't going to work in 11 weeks, but here's what will work. And how can I get that data? Well, on the second tab of this workbook, I've created a Monte Carlo simulation here with 10,000 trials, right? If I come all the way down to the bottom of this, you can see I've got 10,000 trials in which I've gone through and I've ordered each one of these 10 components. So each one of these columns C through L, each one of these 10 columns represents one of the components. And you can see here by the formula, we've come in here and we've come into the norm.inv function in Excel. We've gone in with our probability. We're pulling a random number. That means it's between 0 and 1. So it might come out with 0.4326789. It might come out with 0.9876543. We don't know, and that's the beauty of this. It's coming out with whatever number it comes out with, and it should be a different one every time. So the probability is randomized. The mean is going to be the mean up here, which is 10. We already know that. I also know, and I'll show in the second part of this video, that the standard deviation is 1.89, and this is in weeks. So I go in with a lead time mean of 10 and a standard deviation of 1.89. And all I'm doing here, I've got this wrapped into a rounding function where I round it to 2 digits. It's all, if I didn't do that, this would be 11.65498723597. I just wanted to see this out to 2 digits. It doesn't really matter. But the important thing is here, we do this 10 times for each one of the 10,000 trials. So that's 100,000 different computations are being made here. Now, out here in column N, where it says the title heading, the column heading is max, what I'm looking for here is what is the maximum number of each one of these 10. Why is it the max and not the min that matters here? Well, I'm using maximum because I can't make this product until all of the 10 products are in-house, right? I've ordered 10 different things and I can't do anything with it until the last one finally gets in. So I'm really only interested in the longest lead time. And in this case, it's 11.99 weeks. It's about 12 weeks. Now you can see if you look individually, I have some of these that came in the 10-week window that I would need in order to be able to get this done in 11 weeks. Here in component 2 came in at 9.53. Component 3, it's about 6.87. 8.69 for component 4. 9.05 for 7, 9.88 for 9, and 9.86 for 10. So that looks to me like about half the time it's come in under my 10-week requirement, but that doesn't matter. It's the longest one that counts because I can't do anything until I get each and every one of these components in. So that's why I'm interested in the longest lead time. So I come through here and every single one of these trials, I'm looking for the maximum. Up here in this green box, I forgot to change this back to 10 first. So up here in the green box where it says 7, what I'm looking for here is what is the count? I'm going to count if this number is less than or equal whatever's in this box here. And you'll understand why I did this in a second. Column or cell N9, it looks like, has got a 10 in it. And what this is doing is telling me how many of these are less than or equal to 10. And you can see that there's out of 10,000, I've got 10 instances where all 10 of these came in less than my 10 weeks. And that's 0.1% of the time. Totally unacceptable. We already knew this was going to happen. We said that we thought it would be 1 in 1,024. So this shouldn't be a big surprise. But the reason why we've made this a variable is now we can change this number and see what happens. What if I had 11 weeks? So every time I change this number, it's going to rerun all 100,000 of these cells and it's going to recalc. Well, now I've got 296 out of the 10,000. That's 2.96%. It's better than it was, but still not nearly good enough for me to go back and give them a thumbs up. What if I went 12 weeks? Well, now I'm at 21%. Better? What about 13? I'm over half now. Now I'm basically more than a coin toss. If I have 13 weeks, I've got more than a coin toss. I'm still not going to hang my hat on this. I want to have a little bit more of a buffer. I'm up 84%. Now we're getting close, right? What if I was at 15 weeks? 15 weeks, I'm at 96%. So if you give me 15 weeks for the product to get in, I'm going to need one more week to complete this into a finished good. So I would need 16 weeks total. I'm pretty comfortable, but let's just see what if I went one more week just to make sure. 99.3%. I'm really comfortable with this. So what I can do with this data now is I can go back to my executive team and can say, guys, it's not going to work in 11 weeks. We got pretty much close to a 0% probability that I'm able to support that. However, if you can give me 17 weeks, that means I need 16 weeks to get the product in here, 1 week to turn it into a finished good. With 99% probability, I'm pretty sure we're going to be able to do this. In fact, I'm pretty comfortable even with 96%. So for 16 total weeks, let's go ahead, and if you'll delay this for 16 weeks and not 11 weeks, I'm really, really pretty certain that we're going to be able to support this. Okay, so that's how you can use analytics in order to be able to do some real quick analysis and get back to your team real quickly and tell them, hey, A, no, what you want to do is not going to work. But B, you can be the hero and not just tell them no, but say, no, but if we do it this way, if no, not in 11 weeks, but if you give me 16 weeks, 15 weeks to get the product in here, another week to put it together, I'm really comfortable that I can support that. Now that's where you're going to make some real points for yourself. You're going to provide value. You're going to be using actual data and some analytics to be able to support a decision that you've made with your team. Okay, so I hope this was helpful, and I hope you see how you can use a very simple tool like this Monte Carlo simulation. Extremely easy to pull this together. Okay, in the second half of this video, actually part 2 of the video, which we'll do next, I'm going to show you where this data came from and how you can create a table like this with the data. So thanks for your attention, and look forward to the next step of this where I show you how to actually use the data.